Okay, our last example is Ruth the Radical. Ruth the Radical, we already figured out intervals of increasing and decreasing for this radical. Now we're going to figure out whether this radical is concave up or concave down and where those intervals occur. So we need to find the second derivative. In this case, it might be helpful to actually go ahead and distribute the x times x to the 1/3 multiplied by x plus 3. When we do that, we end up with x to the 4/3 plus 3x to the 1/3. Taking the first derivative, we find we get 4/3 x to the 1/3 plus x to the negative 2/3. The second derivative will be 4/9 x to the negative 2/3 minus 2/3 x to the negative 5/3. That's all power rule right there. It'll be helpful when we find our critical points to actually have this factored out. Notice we can take out a 2/3 from both parts and an x to the negative 5/3, which is the lowest power from both parts. When we do that, we're left with an extra x right here, 1x less. So therefore we're going to end up with 2/3 x to the first minus 1 when we factor out. Our critical points are going to be wherever f double prime is equal to 0 or wherever f double prime does not exist. Those will be when we have the 2/3 x to the negative 5/3 undefined, which will happen when x is equal to 0, or whenever the 2/3 x minus 1 is equal to 0, which will happen when x is equal to 3/2. These are both important critical points that we need to make sure that we identify and put on our sign test. People oftentimes forget the x is equal to 0 part. Make sure that you rewrite this as 2/3 over, or 2/3 times 1 over a cube root of x to the 5th. That'll help you determine that the denominator can't be equal to 0, and that'll happen when x is equal to 0. When we get to our sign test, we've got those two critical points, 0 and 3/2. Here's our second derivative right over here. We're going to test a number that's less than 0. Let's say x is equal to negative 1. When we do so, we get a negative here, and we get a negative here. Negative times a negative is a positive. A number in between 0 and 3/2 would be x is equal to 1. When we plug in x is equal to 1, we're going to get a positive here and a negative here. A positive times a negative is a negative. A number bigger than 3/2 would be something like x is equal to 2. You're going to get positives all around. So a positive here. Here's the basic concave up, concave down shapes of what we're looking for here. The function altogether is concave up from negative infinity to 0 and from 3/2 to infinity, because f double prime is bigger than 0 on those intervals, as we can see from our sign test, and concave down from 0 to 3/2 because f double prime is less than 0 on that interval.